All right, here in our AVL tree class, I'm going to add a new method. Private AVL node, rotate left. We give it an AVL node called root. Now, what should we do here? Well, back to our notes. First, we need to get a reference to the right child of the root node and call it the new root. So, var new root, we set this to root the right child. Next, we should perform the rotations. So we set root dot right child to new root dot left child. Next, we set new root dot left child to the old root. We're done with the rotation. Now we need to reset the height of these two nodes. So root dot height equals math dot max of height of root dot left child. Let me put this on a new line. And height of root the right child plus 1. But wait a second. We already had this logic somewhere else. I don't want to repeat this multiple times. So I'm going to declare another helper method for setting the height of a node. So that's going to be very easy. Private void set height. We give it an AVL node. Now, I'm going to move this logic into our new method and rename root to node. That's better. Finally, we call the setHeight method and give it the root object as well as the new root. So here's our rotate left method. Finally, we should return the new root. We're done with this. Now let's implement the rotate right method. That is very easy, very similar. So real quick, private AVL node, rotate right. We give it an AVL node. Once again, we get a reference to the new root, which happens to be the left child of the root node. Now we set root, the left child, to new root, the right child. I hope you figure this out on your own. And new root, the right child, to the old root. And similarly, we should reset the height of the root node as well as the new root. And then we'll return the new root. We're almost done. Now, back to our balance method. We should replace these lines with calls to our rotation methods. So here we want to do a left rotation on the left child of the root node. So I'm going to delete this line and call rotate left and give it root the left child. Similarly, here we're going to call rotate right and give it the root node. One more time. Here we're going to do a right rotation on the right child of the root node. So rotate right, root the right child. And one last time, rotate left of the root node. Now you learn that as part of performing these rotations, we're going to get a new root. So we should return that new root from our balance method. Let's change the return type to AVL node. Now here on line 48, once we do the final rotation, we return the new root. Similarly, on line 53, we return this object. And if you get here, that means our root is in balance. So we simply return the same root. Now there is one tricky part to this exercise. Let's look at this scenario where we're dealing with a right heavy root and the balance factor of the right child of the root is greater than 0. So our tree is going to look like this: 10, 30, and 20. In this case, we're doing a right rotation on the 30. So after the rotation, our tree is going to look like this. So when we call rotate right of 30, this method is going to return 20 as the new root. Now we should get this and append it as the right child of the root node. So back in our AVL tree, here on line 52, once we perform a right rotation, we get this new root and set root the right child to this object. Similarly, on line 47, when we do a left rotation, we should get this new object and set root the left child to this object. So this is our balance method. Now, back to our insert method. This balance method is going to return the new root. So we reset the root object here and then return it. Or we can combine these two lines and simply return whatever that is returned from this method. That is better. Also, we can refactor these few lines. Now we can reuse our setHeight method. So we call setHeight and give it this root object. So this is how we implement balancing in AVL trees. Now I understand if you were confused a little bit along the way, that is perfectly normal. This is a fairly complex concept. But trust me, if you watch these videos one more time, it's going to be much easier.